Thank you very much, Fernando. Then now we can start the panel discussion, and let me share my screen again. Very good. Then maybe the first question that I can ask from my side to the other speakers is if they would like to add any takeaway, either from the previous webinar or any highlight that they would like to make that is relevant to the scope of this workshop and to the topic that we are going to discuss today.
Well, let me start, David Cebon. I think that the critical thing is that adoption of electric vehicles can only be done when it's financially at least neutral with diesel or cheaper. And that means that there will be, because the cost of using electric vehicles depends on the logistics task and a lot of details around the logistics task. There are some logistics tasks which you can do at the same cost, possibly, with battery electric vehicle than a diesel, possibly. There are some which are much more expensive with electric vehicles. And it's only going to be the ones which are at least the same cost or cheaper that can be electrified at any particular time. And that depends on the company and on the journey and on the what's being carried and the location of chargers and the performance of the vehicles and all kinds of stuff, much of which will change with time, right? The performance of vehicles, the energy density of batteries, the availability of chargers, all that's going to change with time. And that means that the logistics journeys that are profitable at any one time depends on all that development. So it's not a matter of just changing your fleet now. It's a matter of changing, transitioning the part of your fleet which you can transition profitably now, and then later on, as vehicle performance changes and as charging infrastructure becomes available, you can transition a bit more of your fleet, later. So I think that's the critical thing: is how does the cost compare, and particularly how do the logistics costs compare? It's not just about the capital cost and operating cost of the vehicle. It's very much about, can you do the logistics at the same cost as you can do it with a diesel vehicle? So I think that's the critical thing. In order, if the costs are not cheaper than diesel, somebody else has got to pay. The consumer's got to pay, the shipper's got to pay, the government's got to pay, someone else has got to pay if the costs are more than the diesel costs now, because carriers operate on such a low operating margin of a few percent. So the carriers can't afford increased cost of logistics. It's only going to be where journeys can be done at the same price as diesel that it's going to be possible to transition. So that's a complete constraint on the whole business. Back to you.
Thank you very much, David. And Andrea, please.
Yeah, my only comment is about, let's say, the actual capacity available in the battery that you can use. So it was mentioned that, for instance, 65% is one of the, let's say, limitation that you can have. I just wanted to underline that it depends on the models of the vehicle that you have in use. So it depends. The kind of values of vehicles have a limitation of 20%, 30%, whatever. But it's important to underline once again that that kind of limitation is not what you have to preserve when you use the vehicle. It's simply it's simply something that you cannot reach. So it's let's say available in the truck, but not available for the carrier. So if you reach, for instance, if your limitation is 70, you reach 70 and the vehicle is stopped. So that's important. One important element to to have in mind when we read, let's say, statistics or marketing materials coming from IOMs, which says that the battery pack in the vehicle is 540. Okay, fine, but we need to understand which is the actual availability of the battery that I can use as a carrier. Thanks.
Thank you, Andrea. Very good. Then we can open the discussion with the questions that we are receiving on Slido. And the first question that also has the most votes is, how are you currently scheduling the charging moments of your EV fleet? So please, from the panelists who would like to take up on this question.
I can manage it. Let's say that right now, I would say that it's not a big deal, and the reason is that the usability of the vehicle is very limited to certain kind of use cases. Therefore, normally speaking, you have loading and unloading points, and then you can back. So it's A to B, B to A. And normally speaking, you use just one charger. It can be in the depot, or can be in the middle between the 2 points. But no, practically speaking, the use cases where today the electric vehicles are exploited are use cases in which you have a very strong redundancy. Therefore, let's say the scheduling of the charging is kind of expected. You don't have to, let's say, move the vehicle around as you move a diesel truck. The future perspective of the usability of electric vehicles should go in the direction of having a more flexible usage of the electric vehicles, and that will create much more complexity in the scheduling of the charging. If you look at the data of the frame of, let's say, heavy duty vehicles that has been sold in the market, we are right now at 1.5% of the market share for heavy duty electric vehicles. And according to the revised regulation of emission standard, we should reach, let's say, a number that go from, let's say, 30%, 40% of the market share for heavy duty electric vehicles. So it means that we definitely will have to solve the problem of how to better schedule in the charging. Some of the projects that have been mentioned by Fernando are actually trying to evolve the usability of electric vehicles and going to different use cases which are not the simplest one, as I mentioned, A to B, B to A.
Thank you, Andrea. Fernando, please.
Yeah, from my side, I think just to add that when the question says currently scheduling charging moments, currently there is very limited or known use of electric trucks for a heavy duty vehicle in long distance freight transport. For example, I made this question in Transport Logistics Munich in one session we had around electrification, and none of the participants were using electric trucks for heavy duty vehicles, long distance freight transport. So then in that use case is where scheduling charging moments will be critical and very important, and projects like FlexMCS or CFS or Macbeth are looking into tools for that. I also see within the participants list that we have at least 6 or 7 from runners in adopting electric trucks companies. So if anybody in the audience would also want to jump on any of the questions, I think it would be great. You could share your insights and also key associations. So just to be also called that for participants, this is more a workshop. Don't hesitate to raise your hand and jump in to also answer any of the questions.
Perfect. Then David is next. What's your view on this, David? You are still muted.
This is clearly the critical question. So there's a few important things. I think the first is that all the fleets that we talk to, they want to charge on their own premises. They don't want to charge out in the highway. Just as they control their diesel consumption through their own refueling facilities, they do that because they want to be sure of the price and they want to be sure of availability and they want to minimize uncertainty. That's why fleets use diesel bowsers on their, in their depots, in their warehouses. And in the electric world, it's exactly the same. In fact, even more so. They want to have control over the cost of the price of their electricity. They want to have control over the certainty, their ability to charge, to minimize the uncertainty in their operations. And as a consequence, they all want to charge within their own facilities. All the fleets that we're talking to, and that's quite a few. So, and they're UK fleets, and maybe that's different in Europe, but maybe not. I think those issues of controlling cost and controlling certainty, and not being in a situation where you arrive somewhere expecting to charge and there's no charger available, that's not an acceptable situation for logistics when you've got a time slot you've got to hit and so on. You can't afford to just add an extra hour or two in the middle of a journey. So the first thing is charging at base is critical. The second thing is that you can only charge if you, as I said before, if you want the cost of your battery electric operations to be the same or less than the cost of diesel operations, you almost certainly have to charge at times when the vehicle would be stopped anyway. If you add an additional stop, you have to pay for the vehicle, you have to pay for the driver, you have to pay for the cargo. The whole cost of the operation it goes up. So you have to charge at times when you would be stopped anyway. And that means when you're loading and unloading, or perhaps during the driver break. So when you put those together, you have to charge when you're loading and unloading in your own logistics facilities or a logistics facility that you can control. And that is absolutely the preference of all the companies that we talk to at the moment. Now, I think that the point about A to B and B to A is correct to a certain extent. What really matters is that charging is available at the point where you're loading. And often that is round trip journeys. But if you happen to have an opportunity charger and a journey where you are regularly going to the same place, it's perfectly reasonable and possible to stop at a remote location and opportunity charge, and do some sort of multiple legs. In the project that we're running, the demonstration project we're running, which is called Project Jolt, we are building, that's JOLT, you can find it jolt.eco. What we're doing is we're testing the widest possible range of logistics journeys that we can, but we're doing it with chargers that we can move around and we can try them in different places. So we can put a charger at a remote location and opportunity charge at 350 kilowatts, a vehicle at some other location. That means you can try out all kinds of different types of logistics journeys. They may be round, return to base journeys, but they may be multi-dropping journeys. They may be radial pallet journeys. There's all kinds of, they could be long haul journeys, all kinds of things you can do if you have the charging infrastructure in the right place. And in Project Jolt, we're investigating those options using chargers that we can move around easily and try in different locations. So if you're interested in participating in that, you can get in touch with me. But if you look up jolt.eco, you can find out about it.
Thank you, David. And then I see a hand raised from Zeljko Jeftic from Enright. Please, the floor is yours.
Yes, thank you very much. Super interesting discussion on this side. So from Android, we are working on providing the full scope of transport electrification, which is also making us a little bit different from other pure carriers, if I can call it like that. So last week we published a report with Fraunhofer where we were focusing really on showing the benefits of going away from one-to-one replacement of diesel transport operations towards really rethinking and replanning the entire operation of electric trucks and the benefits that can be gained from that. One part of this is also, of course, the charging infrastructure. And what we are doing today is that very often we are charging at customer sites, rightfully as David was just mentioning. If you have possibility to charge while you are loading, unloading, or whenever, that is the optimal solution. On top of that, we are not driving long haul, so we are not driving 1,000 kilometers with our trucks. Nevertheless, we still see that there's a benefit of having public charging stations. So in Sweden, we have launched 7 public charging stations as Enride in collaboration with other partners, where we basically have one hub supplying entire logistics area. And these are open also to all of the other customers, in the same way as we also are using charging stations from, for example, Milence and others. And what is important for us to offer to others, carriers or anybody else, and what is very important for us to get from Milence or anybody else, or Preem or Q8, etc., is really possibility to fix the price, typically over a certain period, so that we have the predictability of what price is going to come. The second thing is very important, to book a time. We want to have guaranteed time. That when we come to a charging station, again, from Milence as an example, we want to be able to charge there, because otherwise it's going to ruin our transport scheduling. And the last thing that we just launched with our latest station in Eskilstuna is now that we are guaranteeing the effect that anybody who is coming out to our charging station is going to get. This is, to our knowledge, the first time that any charging provider is offering effect. But of course, as soon as one has started with this, we are going to see that others are going to start doing that as well, which is great for the overall market. So super important element of charging. And I'm looking forward to hearing how the other ones are doing it as well. Thanks.
Thank you very much. And Andrea, please.
Yeah, just let me, let's say, add one comment building on what David and Zeljko have just said. So David correctly said, when you stop the vehicle, for instance, for the brake of the drive, you need to recharge. That's you cannot create, let's say, new boundaries on the logistic chain. And Zeljko said that basically it's impossible to think to substitute the vehicles, diesel vehicles with electric vehicles without changing the logistics models. So you need to put together these different elements. You need to create different logistics models without creating any new boundaries or impacting negatively on the efficiency of the logistic chain. So how we need to build those kind of logistics models, let's say, is still on the table, in my view. And actually also because no one was considering it as an element from the political point of view, as well as from the IOM's point of view. So it was kind of considered that this kind of systemic change was easier than it is in the reality. So you see right now, also looking at the new topics coming from the European Commission, also pushed by 2.0, which I'm also vice chair too, that right now the focus is also on the logistics and not simply on the vehicles itself, since it's pretty clear right now that if we just focus on the vehicles, we are going to fail the transition towards a more sustainable system.
Thank you, Andrea. Then we can move to the next question. Although looking at the time, I would very kindly ask all the speakers to limit their contributions to 1 minute maximum so we can address all the questions. And the next question is, freight vehicles consumption are strongly load dependent. Shouldn't we permanently update the vehicle model by live consumption measurements? Who would like from the panelists to take up on this? Yes, Stelios, please.
Yes, this is a valid question, and this could be achieved, or this could be incorporated with a live calculation of the fuel or energy consumption of the vehicle. But this has some constraints currently. It requires the communication of the vehicle with a central calculation domain that will always update the routing or the estimated range. This is a very valid point, but I don't know if it is currently mature enough to be implemented on vehicles. Maybe this could be tackled with OBFCM, with the introduction of OBFCM, that vehicles will report their own energy consumption. So this can be addressed in the future.
Great, thank you, Stelios. David, please, what's your view on this? You are still muted.
Sorry, we've got this very sophisticated ways of modeling vehicles. Of course, it's not just the mass of the vehicle. The load is very important, but there's many other factors which are very important. For example, when it's windy, a vehicle uses a lot more fuel. When the road is wet, it uses more fuel. When it goes uphill, it uses more fuel. When the driver has a lead foot, it uses more fuel or more energy, and consequently the range decreases. So all these factors are important. Some of these factors, and in traffic, it uses more energy, depending very much on the speed profile, the starting and stopping. So all these factors are very important. You can do more or less accurate simulations of these things on board the vehicle to calculate the energy consumption, or you can do it centrally. And so we should be, it's very important to have accurate range predictions. If your range predictions are not accurate, you make mistakes that end up with vehicles stopped by the side of the road, unable to move forward, so needing to be rescued. So it's very important to get this right. The techniques and tools are available, and it's something that will improve radically over the next few years, I expect.
Great, thank you, David. Then we can move to the next question, and actually is for you, David. Do we see battery technology improving fast enough to reduce logistics penalties sufficiently?
So that's a very good question. The logistics penalties were two things that I talked about in the previous webinar. There are two logistics penalties that I mentioned. One is a mass penalty, the fact that the vehicle, which is a combination of the mass of the battery and the weights and dimensions regulations, which mean that you can carry a lot less freight on a electric vehicle. And if it's a mass limited vehicle, mass limited load, heavy load like bulk powder or liquid or construction materials or whatever, then what that means is you have to run more vehicles to move the same amount of freight. You might, under some circumstances, need 4 truckloads to move the same amount with battery electric vehicles as you did with 3 truckloads of diesel. And that is the situation at the moment at the heavy end. So it's a small proportion of loads which are mass limited. It's maybe a third of loads, depending on which country you're in and the type of industry that's going on and so on. And that's a difficult one. So what matters there is the mass of the battery, particularly, which is a function of the energy density. And the energy density is improving quite rapidly. Whether it will reach the point where it can reduce the penalties sufficiently in time is a good question. If you had a battery which had twice the energy density today, you could either go twice the distance with the same mass penalty, or you could go the same distance with less mass penalty. You couldn't have both. So there's a long way to go to eliminate the mass penalty before electric vehicles are as good as diesels. The other penalty is a time penalty, and that is the time that you spend sitting on a charger, which is not time that you would otherwise have in your logistics day, and that is a big challenge. And it doesn't really go away. I mean, the number of times, if you've got bigger, higher capacity batteries, the number of times that you have to charge in the day might go down. Might go down from every 4 hours to every 6 or every 8 hours. That's possible, but you still have to charge, and there's still time. So that penalty will gradually come down with time. So both of them will improve. The ultimate problem, however, is not those penalties, but the availability of electricity connections in warehouses, and neither of those problems neither of those penalties or battery technology improvements solve the problem of warehouse electricity supply. You need just as much electricity. In fact, if you have higher density batteries, you might have fewer charging locations, which will mean that they will need even bigger electricity supplies at logistics facilities. So neither of those things go away. That problem is not solved. The whole problem is not solved by improved batteries.
Great, thank you, David. And I see two other hands raised, and I think the next one is from Ralph Willenbroek. Yes, please, Ralph, you are still muted. No, you are still muted. Cannot hear you yet.
If you want, I can go on and then.
Please, Andrea.
My comment is very brief. What David has mentioned are basically a lot of issues that are probably not so easy to be solved if we want to put a deadline in 2030. So once again, if we want to reach the objectives that the regulation of EU has imposed to us, we cannot count on the fact that an electric vehicle in 2030 will run for 2,000 kilometers with one charger that will be happen in 10 minutes, whatever we want, because there will be grid available everywhere. So this is not going to happen. So if this was the question, the answer to me is very easy. It won't happen by 2030 and probably not by 2035 and so on. So once again, if we want to evolve, we have a key point in relation to logistics models. So it's a systemic change, and we cannot simply bring a diesel vehicle out of the work and substituting with an electric truck.
Yes, I understand. Thank you, Andrea. And right,
I think now it's okay, huh? Right?
Yes.
I found the right button. Yeah, I'm Ralf from Ertico. It's a very interesting discussion. What I wanted to highlight is because we from Ertico, we are also doing standardization issues, and there's a lot of convergence between the hardware in the vehicle and the mobile phone, the nomadic device. And I'm pretty sure that this will definitely, there's also standards which go hand in hand with the 14083. And definitely what you discussed, payload is an important issue, and accuracy of the real emissions, because David mentioned how complex this can be. But the standards address this in a quite smart way already. So I think in Macbeth we will have in-depth analysis. And what I wanted especially to highlight, the emission trading system 2 mentioned. I was in a project kickoff where the Commission highlighted it is expected to have 40 billion additional investment into projects, especially supporting the electrification. So I believe that's something we should also keep in mind for the transition.
Thank you, Ralph. And Fernando, what's your view on this, please?
Yeah, yes, to agree with all what it has been said, and maybe it's also transitioning to the next question and what it was mentioned. Actually, emission trading system, it's going to have 65 billion euro that is going to be released, and this has been shared, I think, last year already with our Alice members, and this will go divided per country. The reality is that this 65 billion will go within the scope of emission trading system, and the scope of emission trading system is road transport in general. And so then not only freight, but also vehicles or road private usage and other usages, but also buildings and households. And there is where member states, and we call these member states, define the actual plans on how to invest these billions and decide what is the destination. And our call also together with SEA and IRU was to look into the national transportation. So then the plans in the countries could be dedicated this amount to road freight transportation. And actually, the countries should share these plans by the end of June or beginning July. Normally, this will be delayed, but actually, yeah, the amount that was mentioned, it's a potential, and the reality will depend on where the countries define how to invest this money, and there is many other destinations possible. And in many countries, I have seen a denial on going into electric trucks. So this means that probably in those countries there will not be that funding available, unfortunately, for road freight transport.
Thank you, Fernando. Then we can go to the next question, and it's, let me highlight it. Will road transport be more expensive? For example, penalties for OEMs missing the targets, ETS2, Eurovignet, and others. Would like from the panelists to take up on this question? Yes, Andrea?
Yes, it will. I finished.
Please state it.
So all of these external factors are important, but what really matters is what happens within the industry. And within the industry, you know, we have shippers and carriers. Shippers run with a small carriers operate with a small operating margin, a few percent. They're screwed down on price by the shippers, and it's a highly competitive, low margin industry. Carriers cannot afford increased costs of logistics. If they're operating at, you know, 3% profit margin, and you tell them you need another 25% to account, you know, the costs are going to go up by 25% because of the mass penalty that I mentioned, or the time penalty. They simply can't afford to do that, and they won't do it. Right? Nobody's going to buy more trucks to replace trucks in their existing fleet at the scheduled time, you know, as they roll the fleet over. Nobody's going to buy more trucks if those trucks are not going to be profitable. So the costs will go up. The only people that can carry those additional costs are either the shippers or the government. Shippers can carry the costs by passing them on to their customers, which is basically, at the end of the day, consumers. And the government can pass on the costs to their customers, which is the taxpayers. And actually, the taxpayers and the consumers are exactly the same people. So the people who are going to pay for this is the general public, and those costs have to be passed on. If there are additional costs, they have to be passed on, because the carriers cannot afford, they'll go out of business, right? So either shippers are going to have to step up, or the government has got to have to introduce some regulation which says that the additional costs of electric operations have to be paid for by shippers or have to be subsidized or something, because the costs will go up. They're bound to go up, exactly as the previous speaker said, and it's because there's a mass penalty, it's because there's a charging time penalty, and it's because of the cost of installing infrastructure in warehouses and getting those grid connections.
Thank you, David. Zeljko, please, passing on to you.
Yeah, so I agree with both Andrea and David. The prices are going to go up, but if you reflect on transport that is happening today, are the prices really the correct ones, if I can say it like that? I would say absolutely not. The transport is underpaid today. The transport carriers are underpaid, but still we have quite large amount of inefficiencies in the transport. We still have a lot possibilities to optimize transport further, from how many trucks are used, which are the routes, how many load, etc., etc. We have huge amount of emissions that are coming from transport, and at the same time the governments are subsidizing by billions the fossil fuels. So I think when we are going away from rethinking taking a better grip of the climate change, of the pollutions, of many other issues, there is a need to really rethink the transport industry in itself. That is going to most likely drive the prices up slightly, but I don't believe it's going to be 25% or so. But today's prices are not realistic to continue forever, because we are not taking into account all of the negative effects that transport is providing on our society and our planet.
Thank you, Zeljko. And Fernando?
Yeah, David, your assessment is spot on. It's as simple or as complex as you said. And Andrea and Chelko also clearly said what it is. It's actually true that we are in a transition, and actually there are some levers to make this transition more affordable. The important point here is that if we are not able to do that transition faster, we are not going to have a good or well and healthy enough innovation ecosystem in Europe. And those innovations will happen faster elsewhere, and other stakeholders will know how to handle and how to manage electric trucks much, much better. And that will create an issue for European competitiveness. In particularly when we see other markets in which also trucks may be available on cheaper trucks, and that will have different type of operations. And at the end, I think we are in a transition, and we need to steer that transition to be in the forefront. Otherwise, we may be laggers, and that will potentially penalize not only the competitiveness of transportation, but on the whole economy.
Thank you, Fernando. And Andrea?
Thanks. Now, I would love just to mention for the others which are not, let's say, dealing with the market or logistics right now, just to build on what also Zeljko has mentioned, as Dan and David as well. I always report some numbers that can create a little bit of more comprehension, more awareness on the topic. So if we consider the numbers of the company, for instance, operating in Italy, 10 years ago, we had 110,000 companies operating. Right now that we have just 80,000. So it means that some companies have been purchased, some others have been failed. If you look at the numbers of the vehicles purchased in 2023, it was more than 2024. And actually, just from direct experience, I was in the Transport of Munich fair, and we have been approached of many companies, especially small carriers, that wanted to sell their companies. So this is the actual situation that we have in the market right now. So obviously, if we speak about ETS2 coming in road transport, we need to imagine that new taxations are coming in this kind of situation. So it's certainly risky. I cannot, let's say, estimate the effect, but 100% is risky. it's not the first time that I hear that we will have this kind of 65 billion euro to invest. And when I heard people speaking about it, it seems that those kind of billions are coming from nowhere. Actually, those kind of billions are coming from the market. So definitely the situation will be risky unless, let's say, we will have in a couple of years a totally different market situation in which the economy in Europe will grow once again with a kind of consistent way and durable way. So obviously, speaking about the situation that we have right now, from the geopolitical point of view, we cannot say that things are fine. Let's say, just to be polite.
Thank you, Andrea. Then let's move to the next question as we are running late. It's about David Cebon again, and it's how does the community view the biggest gain points in BEV efficiency? Where do they see the most potential for higher efficiencies and reduce kilowatt-hour consumption? Is it with the inverter, the motor, the drivetrain, or optimizing truck and trailer designs for aerodynamics?
Well, I think it's an interesting question. I think that the community as a whole has not really got the complete understanding of the picture about this, and I don't think there is a general view. What I would say is that that energy consumption of vehicles and of electric vehicles and their range, of course, are critically intertwined. So anything that improves the efficiency of the vehicle improves its range, and that is very, very important. Now, we know exactly what improves the efficiency of the vehicle. They're vehicle improvements like lightweighting, aerodynamics, low rolling resistance tires. They are driver performance, very important, can make a big difference. You can get 10 or 15% difference in range by having a driver with a lead foot compared to a good eco driver that really knows how to drive the vehicle. So I would just say that there's a lot of room for education. I don't think it's really around motor and I don't think the issues are motor and inverter efficiencies. I don't think they're very much in front of anybody's minds because they're already very, very good. You know, they're already in the 95% kind of range, and you can make very small changes there. But if you have a driver that drives badly and another one who drives well and gets, you know, an extra 30 or 50 kilometers as a result, that's a very important thing. So all the things that we used to focus on about vehicle efficiency are even more important in the world of electric vehicles, and they're basically the same issues: tires, lightweighting, aerodynamics, driver performance, all those things. The only thing that isn't important is the efficiency of the diesel engine. Thanks.
Thank you, David. And I see a hand raised from Ralph.
Yeah, I just fully want to support what David said because this also fits to what Andrea mentioned. Everybody knows in the Commission that it is a really tough thing to have this emission trading system too, and it's very political. Think of France, the movements against increasing fuel price. But the hope is to have projects which really make new products which go in the direction of eco-drive, eco-routing. That's why the standardization is also heavily supported. And I think it's very important that the community within Macbeth understands there will be projects where consortia can also apply for investment into the future.
Thank you, Ralph. Very good. Then we can move to the next question, and it's on Stelios. How can simulation tools like Vecto can be improved with real data? What cooperations are needed to make this happen? What are the main gaps and key points to be addressed?
Yes, this is a very specific question. Now, simulation tools need two sets of input data: the vehicle characteristics and historic data or measured data. With the vehicle characteristics, since if we know them in the more detailed, the better. So we can parameterize the model, and then we use the model to compare the results with measurements. Now, if we have measurements, then we can calibrate each component and specific points that affect consumption, as already mentioned previously, and then we can end up with a very good model and a very good prediction. Now, the cooperations needed is mainly data exchange between vehicle owners or vehicle operators with the tools or the people that create and make those simulations. This can be resolved with some over-the-air or monitoring solutions, or with let's say the usage of tachographs and all different inputs from the vehicle.
Great. Thank you very much, Stelios. And unfortunately, I will have to close now the panel discussion because we achieved the time limit. It's 12 sharp. And thank you for all the discussions. And it's clear that there's a lot of practical experience and curiosity in this topic. What we will do now is that we will share with you a summary report with all the questions and inputs from the speakers that were raised during our workshop. With the main points, and this report will be sent to the participants as well as to all IDS TG1 members. So with this said, I would like to thank all the panelists for being present here and for bringing their inputs, and all the participants for making this session interactive with their questions. Thank you very much, and I wish you all a great day ahead.